Welcome to our Scientastic class. I'm teacher Regeline, and I am here to help you understand how science works in everyday life. Are you ready to join me for today's lesson? Come on, let's learn together. Last time, we discussed about the third law of motion, which is the law of interaction, or also known as the action and reaction. The third law of motion states that for every action, there is an equal and opposite reaction. To start with, let me ask you a question. What do these two activities have in common?
They have energy, ma'am.
Yes, in order the roller coaster and the speedboat move, they need energy. Have you ever wondered why do we need energy in order for us to accomplish work or task? It is simply because energy is the ability to do work. When we say work, there must be a force applied to it and the object moves in the direction of the applied force. There are many different forms of energy. Today, we will focus on the two kinds of mechanical energy. Mechanical energy is defined as the sum of potential energy and kinetic energy. We are going to define these kinds of energy. Let's start first with the potential energy. Potential energy has three kinds. 1. Gravitational potential energy. 2. Elastic potential energy. And 3. Chemical potential energy. When we say potential energy, this is simply energy that is stored and waiting to be used later. Ito yung energy na di pa ginagamit.
Example is a pulley. If the object is suspended in a height and it does not move, of course there is a potential energy.
First kind of potential energy is number 1, gravitational potential energy. The potential energy of this is due to an object's position. This means that the heavier the object is, the more potential energy. Or, the higher the object is, the more potential energy.
Examples: a child at the top of the slide, a car that is parked at the top of a hill, and a ripe fruit before it falls.
Number 2 is the elastic potential energy. The potential energy is due to expansion or compression of an elastic object.
Examples: a rubber band and a slinky.
The third one is the chemical potential energy. The potential energy is stored within the chemical band of an object. They usually stored in batteries or even in the food that we eat. The next form of mechanical energy is the kinetic energy. This is energy in motion. Once an object is moving, it possesses kinetic energy.
Examples: windmills, moving archer's bow, and a racing car. Will potential become kinetic and kinetic become potential energy? The answer is yes. This illustrates the relationship between potential energy and kinetic energy. As a biker goes up the hill, he is in motion, kinetic energy, and when it stops and rests on top of the hill, potential energy. As it goes down, kinetic energy.
Usually, we use joules or J in expressing the unit of energy. We also use Newton meter or kilogram meter squared per second squared.
Now, let's proceed on how to solve potential and kinetic problem. Potential energy or PE. We use the formula PE equals M times G times H, wherein PE, potential energy, unit, J or Nm, M, mass, unit, kilogram, G, acceleration due to gravity, 9.8 meter per second squared, H, height, unit, M. Let's try this sample problem. If the light bulb is elevated at 1.2 meters from the ground and has a mass of 0.25 kilogram, what is the potential energy of the light bulb? Given 1.2 meters height, 0.25 kilogram mass. Acceleration due to gravity is constant, which is 9.8 meter per second squared. We are required to find PE. Equation we use, PE equals M times G times H. Our solution, PE equals mass, 0.25 kilograms, times acceleration due to gravity, 9.8 meter per second squared, times height, 1.2 meters. Answer, PE equals 2.94 joules. Kinetic energy or KE. Formula, KE equals 1/2 times M times V squared, wherein KE is kinetic energy, unit J. M, mass, unit kilogram. V, velocity, unit meter per second. Let's try this. The swimmer's average velocity is 1.2 meter per second. If the mass of the swimmer is 60 kilograms, calculate the swimmer's kinetic energy. Our given 1.2 meter per second is the velocity, 60 kilograms mass. We are required to find kinetic energy. Equation, kinetic energy equals 1/2 times M times V squared, or kinetic energy equals 0.5 times M times V squared. Kinetic energy equals 0.5 times 60 kilograms times 1.2 squared meter squared per second squared equals 0.5 times 60 kilograms times 1.44 meter squared per second squared. The answer is kinetic energy equals 43.2 joules. The kinetic energy of the swimmer is 43.2 joules.
This is all for today, class. See you on our next episode. Bye!